Corrosion is a chemical reaction that happens usually on metal when it is exposed in open air, but it can also happen under the ground. This process depends on the solid type. The most common consequence of corrosion of metal is that it becomes thinner. This is a problem. Why? Well, gas pipes under the ground might explode in any time due to leaking if there is no regulation. Even if there is a regulation, how do we know that the gas pipe is going to leak? The interesting fact is that we can predict this before it happens. You might wonder, how? Well, we need data samples and a laptop or a computer. We have used a lot of data sets and experimented with all sorts of data to get a better view of the actual problem. Now, to describe it as compact as possible, with this corrosion project, we aim to develop a model that estimates the corrosion growth in pipes. Our goal is to determine which replacement method of pipes is the most profitable. The methods we consider are divided in two policies. We observe random replacement of gas pipes and replacement based on the corrosion growth model. Oh, and just a small fact, we do all of this with R. Let's have a look at what we have. The data we need comes from some device we call pigs, and we have 4 of them. And no, not those pigs, but this machine. They measure the amount of pipes wall removed by corrosion. To simplify the problem, let's assume that we have true value of this amount. Then, we can actually determine how the accuracy of each pig is distributed. The calculation of this accuracy is done by computing the measurement error. We took the difference between the true value and the value measured by the pig. After that, we made some plots. We used them to determine which parametric distribution would be appropriate to model the data. We experimented with different distribution, but finally came to the conclusion that the measurement error is normally distributed. And if you're wondering how we conclude that, well, we use hypothesis testing. All of this could be done due to the fact that we've had all the information we needed for this puzzle. But we also assume that the amount of wool decreases linearly over time with an unknown rate. Let's call it A. We have 52 gas pipes, and for each pipe, we know their wall thickness measured at a certain time, with the same measurement devices, of course. With this data and the fact that we also know how the measurement error varies, we can estimate the corrosion rate for each pipe. So we have 52 estimated corrosion rates, and that's good, because now it is possible to know how corrosion rate is distributed by analyzing the estimated corrosion rates. We tried the uniform beta, gamma, and exponential distribution. Using the same testing procedure as the previous one, we came to the conclusion that the uniform beta and gamma do give a good approximation for the corrosion rate. The question was which one we should use. To this end, we used AKIK information criterion, AIC method. We came to the conclusion that among these 3 candidates, the uniform distribution was the most appropriate one because the AIC value is the smallest. After determining the distribution for the corrosion rate, we can finally do the main research, which is comparing the 2 policies as mentioned before. We have a data set containing the values of 180 pipes. For each pipe, we also know the age. With this corrosion growth model, we do some simulation. In each simulation, we assign the corrosion rate, which comes from the uniform distribution. We then use the 2 policies to compute how much we have paid in a year in each simulation. Then we add up all of the costs from every simulation and compute the mean. Using this mean, we can conclude which policy is better. In our case, we have done 1,000 simulations. Here are the results. The conclusion is that policy 2 is the one that is profitable. The mean is lower because with policy 2, we replace the pipe before they are going to leak, thanks to the corrosion growth model. Replacing a pipe that is leaking is really expensive and we do not want that. Well, that's it. Thanks for listening. Bye.